Hi everyone, I am Darshan from Department of Computer Science and Engineering, Sri Venkateswara College. Today in chemistry we are going to discuss about the topic batteries. At first let us see about introduction to batteries, then components of batteries, then classification of batteries and some examples of batteries. At first, introduction to batteries. A battery is a portable device that stores chemical energy and converts it into electrical energy. It is made up of one or more electrochemical cell that uses chemical reactions to generate electricity. Batteries are essential for powering a wide variety of devices from our smartphones and laptops to our cars and toys. They are a vital part of our modern world. The most common type of battery is the disposal battery, also known as primary battery. These batteries are designed to be used once and then thrown away. And one more type of battery is rechargeable batteries, also known as secondary batteries. These batteries can be reused many times by being plugged in into a charger. Then let us see about basic components of a battery. A basic battery consists of three main components that work together to generate electricity through a chemical reaction. At first, electrodes. Anode, negative electrode. This is where the party starts. During discharge, the anode undergoes an oxidation reaction, meaning it gives up electrons. These electrons then flow through the circuit to power your device. Common anode materials include lithium, zinc, or graphite. Then comes cathode, positive electrode. Imagine this is the electron acceptor. The cathode attracts the electrons flowing from the anode during discharge and undergoes a reduction reaction which gains electrons. Cathode materials can vary depending upon the battery type, but some example include lithium cobalt oxide, nickel oxide, or manganese dioxide. Then electrolyte. This is the bridge between the electrodes but not a solid one. The electrolyte is a special solution that allows charged particles, ions, to flow freely between the anode and cathode. It conducts electricity but not directly in its own state and can be liquid, gel, or even solid state in some newer batteries technologies. Then separators. These act as a security guard. It's a microporous membrane that sits between the anode and cathode. While it allows ions to flow freely, it prevents physical contact between the electrodes. This is a crucial because direct contact would cause a short circuit and stop the battery from working properly. These three basic components are the of an battery, and the specific materials used for each will determine the battery's properties like voltage, capacity, and lifespan. Then let us see the classification of batteries. There are mainly three ways to classify the batteries by their rechargeability and their chemistry. At first, primary batteries, which are non-rechargeable. These are the disposable batteries you find in everyday items like toys, remote controls, smoke detectors, and many more things. The chemical reaction inside the battery is not reversible. Once the chemicals are used up, the battery is dead and needs to be thrown away. They are typically cheaper, lighter, and have a good shelf life, making them ideal for low drain devices or single-use applications. For example, primary batteries include alkaline, zinc, carbon, and lithium metals. Then come secondary batteries, which are also known as rechargeable batteries. These are the batteries you find in like laptops, smartphones, cameras, and many other digital devices. The chemical reaction within the battery. Their chemical reaction within the battery can be reversed by applying an electric current. This allows you to recharge the battery and use it again many times. They are more expensive initially than disposable batteries, but they are more economical and environmental friendly in the long run as they can be reused hundreds of times. For example, secondary batteries which are rechargeable batteries include lithium ion battery, nickel metal hydride, and lead acid batteries. Then reserve batteries. They are required to be activated whenever needed. They stay inert until needed. This special design allows them to be stored for years without losing power, making them ideal for emergency situations where a device might not be used often. They are activated by a mechanism like a squeeze or spin, then deliver a burst of power before going out. Think of them as a reliable backup power for critical moments. Then let us see some of the examples of batteries. At first, lithium ion battery. Lithium-ion batteries are the most popular rechargeable battery type today. They are known for their higher energy density, meaning they can store a lot of energy in a small size and long lifespan. They power a wide range of devices including laptops, smartphones, tablets, cameras, power tools, and even electric vehicles. Like any battery, a lithium-ion battery works through a chemical reaction that generates electricity inside the battery. There are three main components of a lithium-ion battery. At first, anode, typically made from lithium metal or graphite. During discharge, lithium ions are released from the anode and travel through an electrolyte solution. Then cathode, made from various metals like lithium, cobalt oxide, nickel, manganese, cobalt, or lithium iron phosphate. During discharge, the cathode attracts the lithium ions from the anode. Then electrolyte. Electrolyte is a solution that allows lithium ions to flow between the anode and cathode, but not electrons. The electrolyte can be liquid, gel, or in a solid state. As lithium ions move from anode to cathode, electrons flows through an external circuit power your devices. When the battery is charging, an opposite reaction occurs. The electricity from the charger pushes lithium ions back from the cathode to anode. Now let us see sodium-ion batteries. Lithium-ion batteries have dominated the rechargeable batteries market for decades, powering our laptops, smartphones, electric vehicles. However, a new challenger is emerging: the sodium-ion battery. Why sodium? Lithium, the key element is lithium-ion batteries, faces some drawbacks. Limited resources. Lithium is a relatively rare element and concerns exist about the long-term sustainability of meeting growing demand. And geopolitical issues. The geographical concentration of lithium resources can lead to price fluctuations and supply chain vulnerabilities. Then, sodium on the other hand offers a significant advantage such as abundance. Sodium is one of the most abundant elements on Earth, making it readily available and affordable resource. Wide distribution. Unlike lithium, sodium is found in many locations around the world, reducing dependence on specific regions. Both lithium-ion and sodium-ion batteries functions based on the movement of ions between electrodes during charge and discharge cycles. They share a similar cell structure with anode, cathode, separator, and electrolyte. Now a conclusion. Batteries, from the pocket-sized power source in your phone to the large powering electric cars, are the silent workhorse of our world. We explored their inner workings, however different chemistries create electricity, and the advantages of reusables versus disposals. The future is bright with continuous improvements in existing technologies and the rise of contenders like sodium-ion batteries. As our reliance on portable power grows, so too will the innovation that keeps up charged up. Thank you.